Guys reading.
Hi, we did our project on Steganography. My name is Evan Souza. I made the GUI for all the functions together.
And my name is Nathan, and I did the recovery functions.
And my name is Roman, and I did the embedding functions with the flatten function. That's it. Okay, so this is our flatten function, and what this function does is that it finds the darker pixels and sets their value to 1, and it finds the lighter pixels and sets the value to 0. And just as you can see, we use this using this loop. That's it. Okay, this is our embedding function, embedding technique 1. We have layer, flattened image, and dog image as input. The layer is gonna have values of 1 to 3, 1 being blue, then green, then red. Red, green, blue. The flattened image is just the image that we will be hiding in the dog image, and the dog image is where we're gonna have the hidden images. So here we're gonna index the black pixels, where the flattened image is gonna have a value of 1. And here we're indexing the white pixels, where the flattened image is going to have a 0. What this even index does is that it indexes the pixels, the elements in the dog image where the value is even, and the odd indexes the odd values in the dog image. Now we have black and even, which is a combination of having the black index in the black and white image and having an even number in the same spot for the dog image. And when this happens, we want to make this channel, we want to decrease the value by 1, so it will make it odd. So if we have 120 there, so it's even, and if it's black in the black and white, it will subtract 1 from it to make it odd. And so the other one is just the same thing but in the other way around, vice versa. So that's our embedding technique 1. Now embedding technique 2. Alright, same idea here. Layer as input, flattened image as input, and the dog image as input. Here what we are doing is first we change the dog image into binary format, where each number will be represented in 8 binary numbers, so zeros and ones. Here we have the binary. Then we reshape the image we want to hide into 1 column. Then what we do is that we put that reshaped image into the dog image in the binary format in column 7. Okay, and then basically that's what we did. So now we have the image that we want to hide in 1 column, and we put it in the dog image in column 7 when it is represented in the binary format. And then we just change the dog image back to decimal, and now we have the image stored in that dog image. And embedding technique 3 and 4 are exactly the same as the second one. We're just using column 5 and 6 to store the image we want to hide in. That's the only difference.
Hi, I'm now going to be explaining the 4 recovering methods we made for our group, and they're named Decode 1, Decode 2, Decode 3, and Decode 4. And how Decode 1 works is that we create a 400 by 400 empty array, and then we get the indexes of the odd and even elements of the dog image. We use these indexes to have the 1s at the odd indexes and the 0s at the even indexes. Now moving on to method 2, which is called Decode 2. what we do over here is that here we change the layer of the dog image where we embedded the hidden image from decimal to binary, where we index the 7th column of the dog image in binary. Then we reshape this column 7 into 400 by 400, and this is the retrieved hidden image. I'll be later explaining how to convert from decimal to binary and binary to decimal. And decode 3 and decode 4 are similar to decode 2. The only difference is that we take the 6th column and we take the 5th column where we convert from decimal to binary, and we reshape it back to a 400 by 400 matrix, and this is the retrieved hidden image. And then moving on to expand, here we index the black and white pixels from the hidden image by getting the index of the flattened image where it is 0 or 1. The black indexes are referring to where it is 1, and the white is referring to where it is 0. Then we change the flattened image indexed by the black index to 0, so it shows black. Similarly, we set the image indexed by the white index to 1. Then we create an empty array of the same size as the original non-flattened image. We set each layer of this empty array to be the unflattened image after the previous operations within the function. So today I'm going to be explaining how to convert binary to decimal and vice versa. So basically this is how it works. So binary means there are 2 numbers, that's 1 or 0, and decimal means there are 10 numbers, that's 0 to 9. And how this works is that in the binary numbers, it's basically we need to take them as true or false, with true being 1 and false being 0. So for example, I've written the number like this. So how we take this is at the units place, it's 2 power 0, and at the tens place, it's 2 power 1, and at the hundreds place, it's 2 power 2. So everywhere it's 0, we don't take any number, so it's basically 0. And at the 2 power 2 place, it's true. So since it's 1, we take that into consideration, so 2 power 2 is 4. So 4 plus, and it's false over here, false, so we ignore 2 power 3 and 2 power 4, and we take 2 power 5, which is 32. And hence, we get 36. That's how binary code works. And here are a few examples of how it works. So this is basically at 2 power 9, and this is basically at 2 power 8, and this is at 2 power 5, and this is at 2 power 2. So remember, it always goes from 2 power 0 all the way to 2 power however much you want to. But in this case, we're taking it up to 9.
Hi, this is our graphic user interface that we made. This is our first push button. You load up an image, so we load up the dog image. And this is another push button where we load up the secret image. We decided to load up this one. And we have a choice between 4 embedding methods. All these 4 are push buttons, so we decided to do embed method 1. You choose which layer you want to embed it in, so we choose the red layer. And then we're going to save this as test. Yes. So if you want to load up that embedded image that we just saved, you click this push button and you open it up. And then you have another choice of 4 recovery methods. And then you choose the red layer again. And there it is. This is your hidden image that you hid inside this dog image, and you just got it back. Alright. Go. So this is our main code where you saw those push buttons. This is the functions that it creates. And inside these functions, you call your other functions. Like say, for this one, this is our method 1, or embedding callback. You would call your flatten function to flatten the secret image. And then you would call your embed function to embed your picture inside the dog picture. So this is where you would call all those things. And then you would also put back that embedded image into the axis 3, which is where you saw the embedded image. To recover it, we have functions at the bottom of our code that recover it. So say here we call decode 1 to recover the image, and then we display it in axis 5. And that's pretty much all we do.